Today we are going to start with the solutions of homework questions. So the first solution is on your screen. The distance between two rails of a track is 1.8 meter along a curve of radius 600 meter. Now while describing this part, I want to describe one thing, that is about this 1.8 meter. Many times you may also see the same type of numerical like this way. A broad gauge track is taking turn along a curve of radius 600 meter. So whenever you are going to read the broad gauge track word, obviously broad gauge track is always of 1.8 meter. Don't forget about it. Broad gauge track is always having distance between two rails is 1.8 meter. There are three different types of gauges: broad gauge, meter gauge and narrow gauge. Broad gauge track is 1.8 meter, narrow gauge is 1 meter, meter gauge is 1 meter and narrow gauge is 0.8 or 0.6 meter. In India, meter gauge railways are there. So generally, we are going to choose meter gauge railway over here in our country. But in our country only, for hilly areas, we are going to work with narrow gauge. So in which areas we will see narrow gauge? The train from Siliguri to Darjeeling, or train from Kalka to Simla Manali, train to Matheran. All these trains are also named as toy trains. These are narrow gauge trains. These narrow gauge trains having very small distance between two rails, and therefore the speed is also very small, very minute. You can see this narrow gauge train in few movies also, that is especially Buffy movie. If you seen Buffy movie, then in that movie narrow gauge trains are there. So the distance between two rails of a rail track, it is broad gauge. This is the broad gauge railway. So broad gauge 1.8 meter along a curve of radius 600 meter. Means suppose this is a one rail and this is the another rail. You may ask me question, sir, how this is the first rail and this is the second rail? Rails are like this way, no? This is the one rail, this is the another rail, and train is going to travel from this. But if you are going to check, or if you are going to see these rails from this side, you can observe only the step. Is it right? So that's why after observing the step, you can say that this is the first rail and this is the second rail. Then what I mentioned, the outer rail, second rail is suppose outer rail. Then the outer rail is raised. Outer rail is raised by distance 12 centimeter. 12 centimeter. Centimeter means 0.12 meter. Is it right? So this rail is raised by, so it is over here by 0.12 meter. 12 meter. And distance between these two rails is also given to us, that is 1.8 meter. Further they said, what is the maximum speed with which a train can safely driven along the curved road? So we want to find out maximum speed. Is mu is given to us? No, mu is not given. So while using the formula should be free from mu. So the formula for velocity, what is the formula for velocity? V is equal to under root, the formula for velocity which is free from mu. Mu means coefficient of friction, that is R G tan theta. Is it right? So by using this formula R G tan theta, very good, that is R G tan theta. So by using this formula R G tan theta, we can find out maximum velocity. But the question over here is how to find out theta, but it is not given. See, it's very simple. That length L is nothing but hypotenuse, and this is the height. So when hypotenuse and height means opposite side is given, this is the theta. No? Theta means angle made by inclined surface with horizontal. So this is angle theta. Then this is opposite and this is hypotenuse. So when opposite and hypotenuse, these two things are known, we can use sin theta. Sin theta is opposite upon hypotenuse. So opposite is h, height, divided by L. So by using this formula h by L and putting the values 0.12 divided by 1.8, when you are going to divide, your answer is 0.066. But it is sin theta. Theta is sin inverse 0.066. So theta is equal to 0 degree 22 minutes. Now then, we are having theta. What we want to find out? Vmax. To find out Vmax, let's put values of R and G and theta. So after putting, R is 600 meter. So 600, G is 9.8 and tan 0 degree 22 minutes. The answer is, when you will solve it with the help of log table, the accurate answer is 19.44 meter per second. This is the maximum speed of the train. Okay, let's proceed further and solve next second numerical, which is on your screen. If the circumference of circular track is 2.42 kilometer and car is running safely with speed 24 meter per second, find the angle of banking of the circular track. Can you tell me the formula for angle of banking? What is the formula for angle of banking? Yes, okay, it's very good. The formula stated by student, it is theta equal to tan inverse V square upon Rg. Very good. Tan inverse V square upon Rg. This formula we are going to use. So when we are going to use this formula, no doubt velocity is given to us, but is radius is given to us? I mean so not. But circumference is given to us. So from circumference we can find it out. What is the formula for circumference? Circumference C is equal to 2 pi R. Is it right? So obviously, what is the value of R? R is equal to C upon 2 pi R. Sorry, 2 pi, not R. So what is the value of C? 2.42 kilometer. So 2.42 kilometer means 2420 meter. So put in 2420 divided by 2 into pi, 3.14. When you will solve it, the answer is 385.35. This is value of radius R. Now let's substitute this R over here at this place. So substituting the values, V square 24 into 24 divided by 385.35 into 9.8. The answer of theta is 8 degree 40 minutes. Like this way you can find out theta. Now we are going to move towards very interesting fact, that is VCM, vertical circular motion. But before discussing VCM, first let's see one video. Okay, video is on your screen.
Take a look at this. You're just going to use a clear balloon. So you're going to go to the store and you're just going to buy a clear balloon.
Okay.
And in that clear balloon, you're going to put a penny. So I already put one together for you. So this one will be yours.
Okay.
So the penny goes into the balloon like this. And now you blow it up. So remember when you went to the circus as a kid, that guy in the motorcycle?
Yeah.
And he would go in that cage and kind of go round and round? Centripetal force, not centrifugal, but centripetal. So watch this. You're going to hang on to it and shake it up a little bit and then spin. And as you spin like this, you get this beautiful spinning penny sitting inside. Isn't that just gorgeous?
Oh, that's so cool.
It just goes around
See,
and around and
there is one balloon and inside that balloon he put one coin, and how the coin is moving. What is the motion of the coin?
That's sitting there just around and around and around.
Yes,
Now,
it is a circular motion.
space shuttle, the difference between
So the coin is performing circular motion.
is that up in space that would just keep going and going and going, but of course the effects of gravity
Here
continue to
pulls
pull it down. Now, this is a nice quiet activity, and most teachers like quiet activity at the end of the year, but you don't. So here's what I want you to do. This is the perfect thing. This is a hex nut. So you find a hex nut and you drop it down inside here. Imagine a room. I just came back from
So same experiment he is going to perform with hacksaw nut and balloon.
at the same time. Spin that one and listen to that one.
Oh, my finger got it.
This is a screaming penny, which is just beautiful. So now we get vibration. This is a librarian's worst nightmare, all right? Hey kids, let's go and examine science a little bit. Isn't that fun? Centripetal force. But you know the one that everybody wants to see you do, of course, is this. And so here is the device that of course you're just going to want to make it home. Because why would you want a spoon if you're going to stir up your liquid?
Right.
You need this tray, all right? So the tray goes like this. Is that kind of nice? And now to that tray, we put a glass of water, which is nice. So a little glass of water.
And this is the interesting part. For this, I want to show you this video. Now this is VCM, vertical circular motion. Check what is going to happen over here.
Gosh, was it fun seeing a meteorologist spin this over
And I'm wearing
her
white
head.
today. I'm so
Okay, you're
glad
gonna be
I
great.
heard about
All right,
this
you're feeling
experiment
good?
before.
All right, good. So
Feeling
now
good.
here's what I want you to do.
Yeah.
You're gonna get a little just kind of rocking action. That centripetal force. It's a center-seeking force. Ready? Kind of
Not
up and
even
over here.
kidding you.
1, 2, 3. Up and over your head. Here we go. Nice. See, you did it. You did it. Go again. Come on. Be brave. Be brave. Nice.
Now check this.
It's okay. It's okay. They're just like
everywhere.
$100,000 million cameras, but you're fine. At least the dinner party had one left.
And this thing we are going to discuss over here. Initially, if you seen, the glasses are not ready to fall down, but next time all glasses fell down. What is the reason behind it? Initially, why glasses remains over there on the board only, and afterwards what happened that glasses fell down? This thing we are going to discuss soon, but before that, let's work with basic concept of VCM, that is vertical circular motion. Initially, object means the thread is like this way, that is OL, and object is at point L, means bob is at point L. After some time, this bob will reach at point P. After some time, the bob will reach at point P by making angle theta. The tension initially at point L, tension is acting in which direction? Tension is going to act exactly in upward direction. And over here at bottommost point, means at L, weight mg is going to act in this direction. But when object will reach at point P, what will happen? When object will reach at point P, tension will act again towards the center only, but weight is going to act in downward direction. But now we are going to resolve this weight over here. You can ask me question, sir, over here, why we are going to resolve weight? When we discuss conical pendulum concept, in conical pendulum, we resolve tension. Is it right? We not resolve weight. Then why we are resolving weight? See, what is the condition of resolution? I will show you on the whiteboard. Pay attention carefully. See, in case of conical pendulum, now our bob is over here at this point. After some time, bob will reach at this point. After some time over here, then over here, at each and every point. This tension, when we are going to consider, for tension we have to join this line. What is the direction of weight and what is the direction of tension? At each and every point, see, I will show you. At each and every point, tension is perpendicular to the line. See, when you are going to consider a very small part, for this small part, is this weight is perpendicular? Yes. For the very small part, this weight is perpendicular? Yes. For very small part over here, is this weight is perpendicular? Yes. For very small part over here, is the weight is perpendicular? See, this for this part, yes. For this part, yes. For each and every point, weight is perpendicular and tension is not. See, for this line is this tension along the thread, no? Is it perpendicular over here? No, it's not perpendicular. So the thing which is not perpendicular or parallel, that thing we are going to resolve. Take a note of it. Which thing we are going to resolve? The thing which is not perpendicular or the thing which is not parallel, that thing we are going to resolve. Over here, weight is perpendicular at each and every position. Therefore, we resolved. So therefore, we not resolved weight, but in VCM, in vertical circular motion. Now, what will happen in vertical circular motion? In VCM, over here, weight is going to act in this direction. Is it perpendicular for small part? Yes. Now small part is like this. Now over here, is weight is perpendicular? Check. For this line and this weight, are these two things are perpendicular? No, not at all. Over here, is weight is perpendicular to this small part? No. Over here, okay, again perpendicular, but over here, weight will act in downward direction. Is it perpendicular? No. In conical pendulum, weight is perpendicular to each and every point. Over here, weight is not perpendicular at all, but on the other hand, tension is perpendicular. Now you may ask me question, sir, how tension is perpendicular? See, now this is the center, no? This is the center. Then this is the radius. Is it right? So this is a tangent. Tangent and radius are always perpendicular, and tension is along radius at each and every point. Tension is along radius along each and every point. Therefore, tension is perpendicular. That's why we are not going to resolve tension over here. Then which thing we will resolve? We will resolve weight. So that's why resolving weight into two components, this mg we are going to resolve into two components, mg sine theta. See, when this is theta, it is but obvious. Pay attention towards the theta carefully. When this is theta, obviously this line is parallel to this line, that is OL, and tension developed angle theta, no? The same line, when this angle is theta, the same line will develop angle theta with parallel line. So as this line is that is mg cos theta, because it is adjacent, and the opposite side is mg sin theta, that is which is opposite to it. So mg sin theta. Then one is mg cos theta, another is mg sin theta. Now, what at mg sin theta? What is the direction of mg sin theta? See, when this is mg sin theta, obviously this is also mg sin theta. What is the direction of mg sin theta? Now motion, suppose motion is anti-clockwise, and yes, motion is anti-clockwise. Initially object is at point L, after some time object is going to reach at point P. So in this situation, what will happen is the direction of mg sin theta is helping the motion, or direction of mg cos theta opposing the motion. Yes, opposing or helping? Yes, correct answer. That is mg sin theta opposing the motion. Mg sin theta over here opposing the motion. You may ask me, sir, how opposing? Again I will repeat. What is the motion? What is the direction of motion? Direction of motion is from L to P, like this way. And at mg sin theta, motion is in this direction and mg sin theta is in this direction. So are these two directions are same or opposite? These two directions are opposite. So mg sin theta factor will oppose the motion. Mg sin theta factor will oppose the motion, and therefore At point L, velocity is maximum as object will start moving towards the topmost position. Because of opposition of mg sin theta, velocity of object will go on decreasing. So it will become minimum at topmost position. And when it will become minimum, again it will vary from minimum to maximum in this direction. Because when object will move from this side to this side, that mg sin theta will help the motion. So within half circle it will oppose the motion, and within half circle it will help the motion. You may ask me, sir, how it will help? See, pay attention. Object, suppose over here, weight mg is going to act like this way. So over here this angle is theta. Is it right? So this is I am going to show with red line. This is mg sin theta. So when this is mg sin theta, this is also mg sin theta. Now in this situation, in remaining half part, mg sin theta will help, and in first half part, mg sin theta will oppose. So that's why velocity will go on over here at the bottom position. Velocity is maximum. It will go on decreasing, 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 decreasing minimum, and again it will go on increasing, 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 increasing maximum. Now, as we discussed, that is, it will go on increasing minimum. It will go again. It will become maximum. But can we find out the values of velocities over here in this situation? Yes, we can find out values of velocities. To find out values of velocities, first of all, we have to think about basic. So what is the basic equation of circular motion, vertical circular motion? See, basic equation of vertical circular motion is tension is acting towards the center, mg sin theta acting away from the center, and these together is tension and mg cos theta together are responsible for centripetal force. Who is responsible for centripetal force? Tension and mg cos theta. As both are acting in opposite direction, we can write T minus mg cos theta is equal to centripetal force, and that is mv square upon r, or T equal to centripetal force mv square upon r plus mg cos theta. As body moves up, both centripetal force and component mg cos theta decreases. Hence, tension decreases from A to B. Now, this is a very important point. See, we are going to think about tension. As we will move upward, suppose this is point A and this is point B, then tension will decrease from A to B. Why? What is the reason behind it? Because tension is also dependent upon value of mg cos theta component. As angle will increase more and more, means as theta will increase, value of cos theta will decrease, and as a result mg cos theta will decrease, and as a result tension will also decrease. Ideally at point B tension is 0. How? That we will discuss after some time. But ideally at point B tension is 0. Getting till this point? At point B tension is 0. Ideally. Now, as I said, what should be the velocity at point A, at point B, and at point C? And these are the conditions. These are the basic conditions of VCM. If now I am coming towards that video point, in that video we seen that all glasses fell down at particular position. Or why? The reason behind it is, if you are not going to follow that particular value of velocity, means value of velocity at point A, which we are going to discuss after some time, should be something particular. At point B should be particular. But if, while suppose this is a bottle with cap is open, and if I am going to hold it like this way and I am going to whirl it in a vertical circle, if I'm going to mention that, I'm going to maintain that particular speed. If I'm going to maintain that particular speed, water present inside the bottle will not spill out. Water present inside the bottle will not spill out if I will maintain the particular velocity. But if I will not maintain the particular velocity, then water will fall down. The same thing happened over there. Initially in that video, that lady uh, whirled it with particular velocity. Because of that, those glasses remain intact over there with water. But as soon as she unable to maintain that particular velocity, as soon as she unable to maintain that particular velocity, all glasses and water also fell down. Is it right? Now we are interested in those velocities. We are interested in those velocities, and for that purpose, the first condition at lowest position. What is the lowest position? See, this is the lowest position, this is the topmost position, and these are the intermediate positions. Now, at the lowest position, theta is how much? Yes, theta is 0. Is it right? At lowest position, theta is 0. Why? Where is the theta? See, this angle is theta. No, at lowest position means this position only. At this position, theta is how much? Yes, it is 0. So when theta is 0, cos 0, 1. What is the formula for centripetal force? See, this is the formula, no? T minus mg cos theta is equal to mv square upon r. So when cos 0 is 1, obviously centripetal force is equal to mv square upon r. So what is the formula for tension then? Tension equal to mv square upon r. It will move towards that side, plus mg. So tension at bottommost position is how much? Mv square upon r plus mg. What will happen at topmost position? At topmost position, object is initially like this way. Is it right? When it will reach over here, how much angle covered? Yes, angle covered is 180 degree. So as angle covered is 180 degree, obviously cos 180 minus 1. So mv square upon r. And as we discussed, tension at topmost point is how much? 0. Now you may ask me, sir, why tension is 0 over here? See, over here weight will act in downward direction and tension will act also in the same direction. Is it right? So tension means there is a tension. When you are going to apply force from both sides, then there is a tension. Over here, both side force is absent. So when both side forces are absent, obviously tension is 0. So mv square upon r is equal to 0 plus mg. Now why plus mg? Over here minus 1, no? Minus 1 and minus 1 plus 1. So plus mg. Is it right? If you want to find out formula for tension, which we are going to find out later. So formula for tension at topmost position is tension is equal to centripetal force. This mg will move towards that side. It will become minus mg. Now, this is the formula which is in front of us. From this, we want to find out velocity at point B. So mvb square upon r is equal to 0 plus mg. This mm will get cancelled. This r will move towards that side, and the formula will become vb square equal to rg, that is vb equal to under root rg. So this is the formula for velocity at topmost position. So velocity at topmost position should be minimum under root rg. If it is greater than under root rg, then also it's okay, there is no problem. But if it is less than under root rg, then all glasses will fall down, as we seen. After some time we are going to study one more video, and at that time we will discuss all these laws with very fabulous, interesting motor vehicle video. Okay, then what we want to find out later? We want to find out velocity at point A. This point, we found out velocity at point B. How much it is? Root rg. So to find out velocity at point A, energy at point A is equal to energy at point B. That is, kinetic energy at point A plus potential energy at point A is equal to kinetic energy at point B plus potential energy at point B. But at point A, potential energy at point A is 0. Potential energy at point A is 0. You may ask me, sir, how? See, simple thing. What is the formula of potential energy? Yes, right. Formula for potential energy is mgh. Over here at point A, height is how much? 0. So when height is 0, obviously potential energy is 0. Potential energy at point A is 0. Then obviously kinetic energy at point A is equal to kinetic energy at point B plus potential energy at point B. Let's substitute values of kinetic energy at point A. What is the formula for kinetic energy? Yes, very good. It is half mv square. So let's substitute value. Half mva square is equal to half mvb square plus mgh. So this is height at of point B, no? So when it is height of point B, obviously this point to this point, this distance is r, and this O to B, this is again r. So height of the bob is AB. AB is how much? 2r. So height is how much? 2r. So at h we will put 2r. And what is value of VB at topmost point? At topmost point we discuss value is root rg. So root rg bracket square. From this mm we can take outside and it will get cancelled. So half VA square is equal to root rg square is rg upon 2 plus 2gr. If I will multiply it with 2, then what will happen? VA square is equal to rg plus 4rg. Is it right? So rg plus 4rg how much? 5rg. So VA square is equal to 5rg or 5gr. So VA is equal to root 5gr. VA square is equal to 5gr and VA equal to root 5gr. Okay, let's proceed further towards next point. Now velocity at point B here, that is root gr or rg. Velocity at point A, that is bottommost point, that is root 5 rg. Is it right? So then energy at point A, that is this is A, and is equal to energy at point C. We discuss only kinetic energy is present, so half mva square plus is equal to half mvc square kinetic energy at point C plus potential energy at point C. Now over here height is how much? Height is r. How? See, object is at C point, no? So this distance is how much? Height. Height means straight line, perpendicular distance. So it is r, radius. Okay. So mgr. Again mm we can take outside, it will get cancelled. If you are going to multiply with 2, then after multiplying with 2, it will become VA square is equal to VC square plus 2gr. Let's put value of VA square. What is value of VA? VA is root 5 rg, no? Rg. So after putting it and its square, it will become 5gr. So 5gr is equal to VC square plus 2gr. That 2gr will get transferred towards that side. 5gr minus 2gr, it is 3gr. So VC square is 3gr. So VC equal to root 3gr. So if minimum velocity at point A is root 5 rg, at point C it is root 3 rg, and at topmost point it is equal to root rg. Then and then only. Over here root rg, root 3 rg and root 5 rg. If these velocities are there, minimum. If greater than it, then also it's okay. But minimum, these velocities should be present at these particular positions. Then only your object can perform vertical circular motion without falling. Okay. Otherwise, it will fall down as we seen in our video. Next, we are interested in energy at three different points, that is A, B, C. So let's discuss energy at point A. Energy at point A is equal to half mVA square, where m is mass of the body. Okay, then what is value of VA? We discussed now VA is equal to, sir, very good, VA equal to under root 5 GR. So when VA equal to under root 5 GR, its square is 5 GR. So if you will substitute this 5 GR at this position, so half m 5 GR, that is 5 by 2 mgr. This is energy at point A. Can you predict anything about energy at point B and energy at point C? Yes, energy at point B and energy at point C should be same, 5 by 2 mgr. How? According to law of conservation of energy, total energy should remain constant. So when total energy should remain constant, energy at point A should be energy at point B, should be energy at point C. So let's work with B and C. Energy at B is equal to potential energy at B plus kinetic energy at B. So what is the formula for energy? Potential energy, kinetic energy. Potential energy mgh. For point B, height is how much? Just we discussed. Height is 2r, is it right? So mg2r, half mvb square. What is value of Vb? Value of Vb is root gr. So substituting this value at Vb, we can write 2 mgr plus half mgr. Let multiply with let find out LCM, and if you are going to find out answer, then it is again 5 by 2 mgr. Is it right? It is 4 mgr by 2. 4 mgr by 2 plus half mgr. It is 5 by 2 mgr. Energy at C. Energy at C is potential energy at point C plus kinetic energy at point C. So energy at point C, potential energy mgh, that is mgr, half mvc square. What is value of Vc? Vc is root 3 gr, no? So root 3 gr square, that is 3 gr. So 3 by 2 mgr. 3 by 2 mgr plus mgr, that is 5 by 2 mgr. So energy at point C is also 5 by 2 mgr. It will prove law of conservation of energy also. Energy at point A is equal to energy at point B is equal to energy at point C. Getting it till this point. Okay. So let's work on tension without taking any kind of tension. So already we discussed this formula and this formula. Is it right? Over here angle is 90 degree. So when theta is not 90 degree, cos 90 is 0. So that mg cos theta term will vanish and tension equal to only centripetal force. But now work with this tension or tension at this point. When we will discuss tension at this point, this is the formula which we discuss, mv square upon r minus mg. But what is value of v at topmost point? Yes, it is root rg. So root rg square is rg. So m into rg divided by r minus mg, rr cancel, mg minus mg. What is the answer? 0. So at this point tension is how much? 0. Over here what is the formula of tension? mv square upon r plus mg. Is it right? Put value m. What is velocity at bottommost point? Root 5 gr. So its square is 5 gr or 5 rg divided by r plus mg. Again rr will get cancel. So 5 mg plus mg, how much? 6 mg. So velocity at bottommost point is 6 mg. What about this? Over here velocity is how much? Velocity is 3 t equal to 3 gr. So m v c square is 3 gr. So 3 gr upon r. Rr will get cancel. So what is the value? 3 mg. So velocity at topmost point is, tension at topmost point is 0. Tension at bottommost point 6 mg, and tension at this point and this point is 3 mg. So 0, 5 mg and at these 2 points it is 3 mg. If you are getting it, let's solve few MCQs. First MCQ is on your screen. The angular displacement theta of the flywheel varies with time as. So angular displacement is varying. It is theta equal to at plus bt square plus ct cube. Then angular acceleration. What is the formula for angular acceleration? The basic formula of angular acceleration alpha is d omega by dt. Is it right? What is formula for omega? Omega is equal to d theta by dt. So let's put values. At the place of theta, we are going to put value of theta at plus bt square plus ct cube. If we will put values over there, then means we, in other words, we are going to differentiate theta with time t. So after differentiation, it is a plus twice bt plus thrice ct square. Is it right? Thrice ct square. This omega again we are going to differentiate, and then alpha is equal to how much? Alpha is d omega. After differentiating this upper part, means omega, it is 2b plus 6 ct. Is it right? So 2b plus 6 ct means b is the correct answer. Second question. Which one of the following force is a pseudo force? Force acting on falling body, force acting on a charged particle, force acting on falling body, gravitational force, which is not pseudo, so is not the correct option. Force acting on charged particle placed in electric field. So force explained by charged particle placed in electric field, electrostatic force. Obviously, it is also not pseudo force. Force experienced by person standing on a merry-go-round. Yes. Over here, the person definitely will experience centrifugal force. So this is a pseudo force. Centrifugal force is a pseudo force. The last one, force which keeps electrons moving in circular orbits. No. Magnetic force is responsible for that to keep electron moving in circular orbit. So magnetic force is also not pseudo force. So obviously C is the correct option. Frictionless track ABCD ends in a circular loop of radius 2 cm as shown in the diagram. A body slides down the track from point A, which is at height h. The minimum value of h for a body to complete loop is, so we want to find out height. Is it right? For that purpose, see, object is placed over here, it is start running towards this side. Initially, which energy object will possess at point A, potential or kinetic? Yes, which energy the object will possess? Yes, potential energy. Potential, so mgh is equal to, now at point B, the whole energy, height is 0. So there is no potential energy. At point B, whole energy will get converted to kinetic energy, that is half m Vb square or V square. At bottommost point over here, first of all mm will get cancelled, gh half. At bottommost point, what is the value of velocity? Yes, at bottommost point it is 5 rg, root 5 rg, no? So root 5 rg square, it is only 5 rg. So gg will get cancelled. So h is equal to 5 by 2 g. Is it right? Sorry, no, not rg, r. What is value of r? Value of r is 2 centimeter, no? So putting 2 over here, that 2 will get cancelled. What is the value? The answer is 5 centimeter. Getting it? Like this way you can solve this numerical. A bottle of soda water is grasped by the neck and swing briskly in vertical circle. Near which position of the bottle do the bubble select? At the bottom, near the neck, in the middle of the bottle, bubbles will remain uniformly. It should be distributed. Yes, near the neck is the correct option. all bubbles will get collected near the neck because of centrifugal force. Because of centrifugal force, the water present inside it will get pushed down towards the bottom, and all bubbles will get collected at the top, means at the neck. So these are the solutions which we discuss. Before proceeding further, we are going to study the one more video. Pay attention towards the video very carefully, and after this video we will stop our session, but don't leave the class. Yes.
Welcome back. Right, I'm really excited about this next item because it's the biggest and bestest thing Fifth Gear has ever done.
Hell yeah, check this out. Who remembers these? Hot Wheels Loop the Loop. Come on, Tom, send one down.
There we go.
Yes, but what we wanted to know is, could you do that in a real-life family-sized car?
Yeah, we gave the job to our friendly neighbourhood stuntman, Steve Trulia, but we wanted some questions answering first. How fast would he have to go? Would the car stick to the road? And would he black out under the G-forces?
Steve Trulia is the man facing this monster challenge. As Fifth Gear's head of danger, he's rolled, crashed and crashed again in numerous Fifth Gear stunts. But even by these extreme standards, nothing can prepare him for our most dangerous stunt yet. Clearly, scaling a toy up to a record-breaking 40 feet high using 5 tons of steel and a real-life motor was going to be dangerous. So we sent Steve to Cambridge University's Dr. Hugh Hunt to find out how fast he'd have to go. Now listen carefully.
2r plus a half v in squared
Starting to
equals
cook my brain a bit now.
36
About
miles per hour.
36 miles an hour.
But you know what we haven't worked out though?
What's that?
Is what are the G-forces you're going to experience? Because you want to know whether you're going to black out or not. The total G-force you will experience as you enter this loop will be
See,
G.
we are finding out the velocity at bottommost and topmost. Bottommost 36 and topmost they found out 69 mile per hour. So if he will follow that much velocity, he able to finish the loop. Otherwise, he cannot.
To do that was in this. And here we go into the loop.
Initially, he is working with aeroplane.
Stunt Day. The day Fifth Gear finds out if you really can drive a car around a 40-foot high loop-the-loop. If successful, stuntman Steve Trulia will set a new world record. If he fails and falls out of the loop, the massive deceleration forces as he hits the ground could be fatal.
It's very dangerous. He will cause accident also. But then also he can finish it if he is going to follow rules of physics.
With GPS. 36, 37. And then checked again with a calibrated radar gun. 36 miles an hour had been calculated as the ideal entry speed.
Just is 38. He has to increase his speed.
Much faster, and the G-forces would knock him unconscious.
Otherwise this may happen.
On the ramp structure. The Toyota Aygo Steve had chosen for the stunt had been heavily modified to make it strong enough and hopefully safe enough should things go wrong.
Here we go, this is it. This is it, we're going in too fast. And here we go.
Yes, he entered. And yes, he able to finish the loop.
Rock and roll! Wow, I did it! Oh, that is fantastic! It was so light at the top. I really thought I'd lost it. I felt weightless. I thought, I'm falling. I'm so glad that I stayed in touch with the road all the way around. As soon as I left the ramp, just a complete feeling of joy and elation.
Dr. Hugh Hunt's analysis revealed how close we'd come to disaster. Just 2.5 miles an hour slower and Steve would have fallen.
And here we go.
1 mile an hour faster and the extra friction caused by the scraping would have made him fall as well. Steve hit it spot on, so take a moment to savour the world record for driving a car around the largest loop-the-loop. Chances are you'll never see it executed so perfectly ever again.
So today we will stop at this point and with circular motion also. Later in next session we are going to work with gravitation chapter. Bye bye. Take care till that point and we will meet again.